Farmers also kept a close eye on their oak trees, which had a reputation for being the wise elders of the forest. There's an old saying, "If the oak leaves out before the ash, 'twill be a summer of wet and splash. If the ash leaves out before the oak, 'twill be a summer of fire and smoke." Surprisingly, this bit of medieval weather wisdom holds up pretty well even today. Oak trees are more sensitive to temperature, while ash trees respond more to light levels, making them natural indicators of upcoming seasonal patterns. In fact, modern research shows that oak trees are right about incoming weather patterns roughly 80% of the time. But it wasn't just the big trees that got all the attention. Small plants had their own weather predicting talents. Take the scarlet pimpernel, nicknamed the poor man's weatherglass. This tiny flower would close its petals tight when rain was coming, usually about 2 to 3 hours before the first drops fell. Medieval farmers joked that it was more reliable than the local weather prophet, who usually just looked at the same flowers and pretended to have special powers. They had a saying, "When the pimpernel's petals close their eyes, rain will make the farmer wise." Dandelions played their part too, though they were probably the laziest weather predictors. When rain was approaching, they would close up their seed heads, refusing to release their fluffy seeds into soon-to-be-wet air. Smart move for seed dispersal, and helpful for farmers who needed to know whether to start their outdoor work. As one farmer supposedly quipped, "If the dandelion's sleeping in, perhaps we should too." Onions and cabbages would grow extra leaves in years when a harsh winter was coming. Medieval farmers noticed this and would adjust their winter food storage accordingly. It's like the vegetables were trying to bundle up for winter. Modern scientists have confirmed that many plants can indeed sense and prepare for long-term weather changes, though they probably wouldn't recommend using your vegetable garden as a primary weather service. Studies suggest that certain vegetables can detect seasonal changes up to 6 weeks before they occur. Mushrooms were particularly chatty about upcoming weather too. A sudden explosion of mushrooms popping up meant wet weather was on its way. This makes perfect sense since fungi thrive in moist conditions and often fruit right before rain. Some medieval farmers called mushroom patches witches' weather marks, though that probably had more to do with general medieval suspicion of mushrooms than any actual witchcraft. One old farmer's diary mentioned that mushrooms sprouting like soldiers' tents meant 3 days of rain was coming. And it's really clever how medieval farmers would combine all these plant signals together. If the pine cones were closed, the poplars were flipping out, and the scarlet pimpernel had shut up shop, you could bet your last medieval penny it was going to rain. It was like having multiple weather forecasters all agreeing at once. Modern meteorologists actually use a similar principle. They look at multiple indicators before making a forecast, just like our medieval ancestors did with their plants. But perhaps the most interesting thing about all this plant-based weather forecasting was how accurate it could be. Studies of traditional weather wisdom have shown that many of these plant-based predictions are correct about 85% of the time, which, let's be honest, is better than some weather apps we could mention. These medieval farmers might not have had satellites or computer models, but they had something just as valuable: generations of careful observation and a deep connection to the natural world around them. But while trees and flowers were busy predicting the weather with their silent signals, down by the ponds and streams, frogs and fish had mastered their own weather forecasting arts. Their peculiar behaviors before storms would prove just as reliable as any swaying tree or closing flower. The frogs, usually content with their regular croaking volume, were suddenly putting on a performance that would rival a medieval church choir. No, they weren't auditioning for Medieval's Got Talent. They were actually announcing an incoming storm. These amphibian weather forecasters were so reliable that some villages reportedly used them instead of church bells to warn of approaching rain. The science behind frog forecasting is pretty fascinating. Studies show that frogs can detect changes in barometric pressure through their super-sensitive skin. When air pressure drops before a storm, frogs get incredibly chatty, probably because they know these conditions are perfect for breeding. Recent research has found that some frog species can detect pressure changes as small as 0.1 millibars, which puts them on par with modern weather instruments. Medieval farmers would often say, "When the frogs sing their evening song, tomorrow's weather won't go wrong." If the croaking reached fever pitch during the afternoon, rain was usually just hours away. One particularly grumpy farmer's diary from 1467 complained about those blessed frogs keeping the whole village awake the night before a massive storm. though you'd think after years of farming, he'd be grateful for the heads up. But frogs weren't the only aquatic weather prophets. Fish had their own way of signaling incoming weather changes. When fish suddenly started jumping like they were trying to escape the water altogether, medieval farmers knew a storm was brewing. This wasn't just random fish gymnastics, the dropping air pressure before a storm affects their swim bladders, making them uncomfortable enough to leap above the surface. In fact, fishing communities developed entire weather prediction systems based on fish behavior. If the fish were feeding close to the surface, it meant fair weather would stick around. But if they dove deep and seemed to disappear, time to batten down the hatches. Modern studies have confirmed this behavior, showing that fish can detect pressure changes of just 2 millibars. That's sensitive enough to predict a storm nearly 48 hours in advance. Then there were the crickets, nature's tiny thermometers. Medieval farmers discovered you could actually calculate the temperature by counting cricket chirps. The warmer it got, the faster they chirped. Modern science has turned this into a real formula. Count the chirps in 15 seconds, add 37, and you'll get the temperature in Fahrenheit. Who needs a thermometer when you've got a garden full of cricket calculators? Spiders turned out to be surprisingly good meteorologists, too. When spiders strengthened their webs and made them shorter, medieval farmers knew fair weather was ahead. But if the spiders started building longer support threads or taking their webs down entirely, storm incoming. One medieval text noted, "The spider works badly before rain, but skillfully in fair weather." Modern archaeologists have found that spiders can indeed sense atmospheric pressure changes through specialized hairs on their legs. Even earthworms got in on the weather forecasting game. When worms suddenly appeared all over the ground surface, rain was imminent. Medieval farmers called this the worm exodus, and it was one of their most trusted signs of incoming rain. Today, we know that worms surface before rain to avoid drowning in their tunnels. They're basically playing a medieval version of "the ground is lava." Medieval farmers noticed that ants would build up the walls around their ant hills before rain. The higher the walls, the longer the rain would last. They weren't just being overly cautious. Ants can detect approaching rain through changes in humidity and air pressure. Recent research shows that ants can sense rainfall up to 24 hours in advance with shocking accuracy. They get it right about 85% of the time. The most impressive insect weather predictors were probably dragonflies. When they flew high in the air, medieval farmers could count on good weather. But when dragonflies suddenly started flying close to the ground, rain was coming, and soon. This behavior is linked to air pressure changes. When pressure drops before a storm, insects that dragonflies hunt fly lower, and the dragonflies follow their food. Speaking of flight patterns, medieval farmers also kept a close eye on where flies landed in their homes. If flies started clustering on walls or seemed more aggressive than usual, rain was on the way. One old farming journal grumbled about flies being more bothersome than the tax collector before storms. And if you knew anything about medieval tax collectors, that was saying something. As the frosty winds of winter approached, these small creatures would show different signs that helped predict the changing seasons. In fact, medieval farmers found that frost patterns told their own unique story about what kind of winter was coming. Medieval farmers didn't just sit around waiting for winter to happen. They were like detective meteorologists, reading every single hint nature dropped about the upcoming cold season. Frost wasn't just a white covering on the ground. It was a complex language that told stories about temperature, moisture, and the harsh months ahead. Early frost was the ultimate winter warning sign. When the first frost arrived earlier than usual, medieval farmers knew they were in for a long, brutal winter. This wasn't just superstition, it was a survival strategy. An early frost meant crops needed to be harvested faster, livestock needed extra protection, and firewood needed to be stockpiled immediately. One farming record from 1389 noted that when the first frost kisses the ground before the harvest moon, winter shall be a harsh mistress indeed. The type of frost mattered just as much as its timing. Hoarfrost, those delicate crystal-like ice formations, was particularly fascinating. When hoarfrost appeared without clouds, medieval farmers knew a dry, cold spell was coming. These intricate ice crystals formed on clear, cold nights when moisture in the air froze directly onto surfaces. Some farmers had such a keen eye that they could predict the duration of the cold spell just by looking at the hoarfrost's density and pattern. Medieval meteorological records show that farmers tracked frost patterns with almost scientific precision. They noticed that certain frost formations predicted specific weather conditions. A light, delicate frost might indicate a brief cold snap, while a thick, heavy frost suggested prolonged cold temperatures. One particularly detailed farming diary from the 14th century included over 50 different descriptions of frost types and their potential meanings. Dew played its own fascinating role in winter weather prediction. Heavy morning dew might seem counterintuitive, but medieval farmers knew it meant fair weather was ahead. When the ground cooled evenly overnight and moisture condensed smoothly, it signaled stable atmospheric conditions. This wasn't just a random observation, it was a sophisticated understanding of how temperature, humidity, and air pressure interact. Interestingly, the location of frost mattered too. Frost that appeared first on low-lying areas indicated different weather patterns compared to frost that started on higher ground. Farmers would walk their fields at dawn, carefully observing these subtle differences. Some regions even had specific local sayings about frost patterns. One old Welsh farming proverb suggested that frost on the north side of the stone wall speaks of a different winter than frost on the south. The color and texture of frost provided additional insights. A bluish-white frost suggested different atmospheric conditions compared to a more yellowish or grayish frost. Medieval farmers didn't have color charts or scientific instruments, but generations of observation had taught them to read these subtle variations like a book. Modern meteorologists would be impressed by the accuracy of these traditional observations. Temperature wasn't the only thing frost could predict. Medieval farmers discovered that frost patterns could give hints about upcoming agricultural seasons. A certain type of frost might suggest an early spring or a late harvest. Some farming communities even had specialized frost readers, respected elders who could interpret these icy messages with remarkable accuracy. Tracking ice formations on water sources was another crucial strategy. The thickness, clarity, and formation of ice on ponds and streams told stories about temperature trends. Clear, thick ice suggested a consistently cold period, while cloudy or uneven ice might indicate fluctuating temperatures. Farmers used these observations to plan everything from livestock management to firewood collection. Medieval farmers didn't just passively observe these frost patterns, they actively used them for survival. If early frost suggested a long winter, they would adjust their entire agricultural strategy. This might mean harvesting crops earlier, protecting livestock more aggressively, or storing extra food. Their survival literally depended on reading these subtle natural signals correctly. Some regions developed incredibly complex frost prediction systems. In parts of northern Europe, farmers would create detailed journals tracking frost patterns, comparing them across years, and developing increasingly sophisticated prediction methods. These were essentially the first climate change records, decades before scientific meteorology became a formal discipline. One fascinating aspect of medieval frost reading was its connection to lunar cycles. Farmers noticed that frost behaved differently depending on the moon's phase. A full moon on a clear winter night often meant more intense, predictable frost patterns. Some communities even had specific rituals and practices tied to observing frost during different lunar phases. As the night approaches, frost and ice whisper their own winter stories, but the moon has been busy telling even more complex tales about the seasons ahead. Its shifting phases hold secrets that, to the trained eye, reveal weather patterns months in advance. Medieval farmers didn't just glance at the moon, they studied it like a living almanac, decoding its luminous clues to prepare for what nature had in store. Medieval farmers weren't just ground-level weather watchers, they had their eyes turned skyward, particularly to the moon. This celestial body wasn't just a pretty nightlight, it was a complex weather predictor that could tell stories about upcoming seasons, storms, and agricultural challenges. A bright, extra-luminous full moon during winter was more than just a beautiful sight. Medieval farmers knew it meant something serious. Clear skies and dropping temperatures were coming. When the moon shone with an almost supernatural intensity on a winter night, farmers would prepare for a hard frost by morning. They'd rush to protect vulnerable crops, move livestock to sheltered areas, and ensure their firewood was well stocked. The moon's phases became a sophisticated weather prediction system. A new moon appearing in a completely cloudless sky wasn't just an astronomical event, it was a sign of an upcoming dry spell. Farmers would interpret this as a signal to prepare for potentially weeks of dry weather. Some agricultural communities even had specific rituals around observing these lunar transitions, tracking them with a precision that would impress modern meteorologists. Not all moon appearances were created equal. A pale, dim moon wasn't just a sign of cloud cover, it was a direct warning of incoming moisture. Medieval farmers understood that a hazy lunar appearance meant rain was likely within the next few days. This wasn't random guesswork. Generations of observation had turned this into a refined predictive skill. Some farming journals from the 14th and 15th centuries contained incredibly detailed logs of moon appearances and corresponding weather patterns. Interestingly, different cultures had their own unique lunar weather prediction methods. In northern European farming communities, farmers would track the moon's appearance during different seasons with remarkable detail. A winter moon that appeared slightly tilted might indicate a more severe cold spell, while a summer moon with a particular glow could suggest an upcoming heat wave. Research suggests that lunar observations were surprisingly accurate. Modern meteorological studies have found that lunar cycles can indeed influence weather patterns, though not exactly in the way medieval farmers believed. The moon's gravitational pull affects ocean tides, atmospheric pressure, and wind patterns, subtle influences that can indeed impact local weather conditions. Some medieval farming communities developed complex lunar calendars that went far beyond simple weather prediction. These calendars tracked not just moon phases, but their appearance, color, and surrounding atmospheric conditions. A farmer's lunar calendar was like an ancient version of a weather app, providing insights into potential agricultural challenges months in advance. The connection between the moon and weather wasn't just about prediction, it was about survival. In an era without modern agricultural technology, understanding potential weather patterns could mean the difference between a successful harvest and total crop failure. A farmer who could read the moon's signals had a significant advantage over those who couldn't. Lunar observations were particularly crucial during planting and harvesting seasons. Farmers would time their most critical agricultural activities based on moon phases, believing that certain lunar conditions provided optimal conditions for crop growth. While some of these beliefs might seem superstitious today, many were rooted in generations of careful observation and practical experience. Different moon phases were associated with different agricultural activities. A waxing moon might be considered ideal for planting crops that grew above ground, while a waning moon was thought better for root crops. These weren't just random beliefs. They represented a sophisticated understanding of seasonal cycles and agricultural timing. Some medieval texts even suggested that the moon's appearance could predict longer-term weather trends. A particularly bright or dim moon during a specific season might indicate whether the upcoming months would be wet or dry, cold or mild. Farmers would adjust their entire agricultural strategy based on these lunar observations. The most interesting aspect of medieval lunar weather prediction was its blend of practical observation and what we might today call folkloric wisdom. These farmers weren't just making wild guesses, they were collecting generational data, comparing observations, and developing increasingly sophisticated prediction methods. While the moon told its complex weather stories, medieval farmers knew that the most immediate weather signals often came from the church bells ringing across the villages, a sound that carried more than just religious significance, but also warnings of impending disaster and changing weather. Long before smartphones and weather apps, medieval farmers had developed an extraordinary skill that might sound almost magical today, predicting weather through sound. Church bells weren't just instruments of religious call, but sophisticated meteorological tools that carried whispers of atmospheric changes across entire villages. When a church bell sound traveled unusually far, medieval farmers knew something significant was brewing in the sky. This wasn't just superstition, it was a precise understanding of how atmospheric conditions affect sound transmission. Changes in air pressure and humidity could dramatically alter how sound waves moved through the atmosphere. A bell that could be heard miles beyond its typical range was a clear warning that a storm was approaching. The science behind this phenomenon is fascinating. Sound travels differently through various atmospheric conditions. When air pressure drops and humidity increases, typical conditions before a storm, sound waves can travel much farther and with greater clarity. Medieval farmers might not have understood the complex physics, but they knew exactly what those extra loud bells meant. Batten down the hatches, a storm is coming. In different regions, this sound-based meteorology took on unique characteristics. Alpine villages developed particularly sophisticated systems where church bell sounds were treated almost like a complex language. The pitch, duration, and reach of the bell sound could communicate nuanced information about upcoming weather patterns that went far beyond simple storm warnings. But church bells weren't the only sound-based weather predictor. Medieval listeners discovered that distant sounds becoming mysteriously clearer was another reliable weather indicator. Farmers could suddenly hear a dog barking from miles away or the distant river's current sounding unusually loud. These were not random occurrences, but precise meteorological signals. Moisture plays a crucial role in sound transmission. Water particles in the air can actually help sound waves travel more efficiently, carrying them farther than they would normally go. Medieval farmers realized that when sounds seemed unnaturally crisp and clear, it often meant rain was imminent. They developed an almost supernatural ability to distinguish between normal sound and rain sounds. The opposite was equally true. When sounds become muted or oddly dampened, it signaled something completely different. Muffled, dull sounds typically indicated high-pressure systems and upcoming dry weather. A village that suddenly seemed wrapped in acoustic cotton was a sure sign of stable, dry conditions ahead. Local topography added another layer of complexity to these sound-based predictions. Villages nestled in valleys or near mountains would experience sound transmission differently compared to open plains. Experienced farmers knew exactly how sound should behave in their specific landscape, making their predictions remarkably accurate. Interestingly, different types of sounds carried different meteorological messages. Church bells had their own language. The way they rang, how far they carried, their tone and resonance all told different stories about upcoming weather. A bell that seemed to sing differently might indicate approaching humidity or pressure changes. Some communities took this sound-based meteorology so seriously that they would assign specific listeners, almost like ancient weather forecasters, whose sole job was to monitor atmospheric sound conditions. These weren't just random villagers, but trained observers who understood the subtle nuances of how sound travels through different weather conditions. Modern acoustic meteorology has actually confirmed many of these traditional observations. While medieval farmers didn't understand complex physics, they had developed an empirical understanding of sound-weather relationships that modern scientists find remarkably sophisticated. Their observations weren't just folklore, they were sophisticated, experience-based scientific measurements. As the sounds of bells and distant echoes faded, medieval farmers recognized that their understanding of weather went far beyond sound. It was a complex symphony of observations that touched every aspect of the natural world around them.